The area and the perimeter of a square are quite familiar to us. There's also a certain kind of intuitive relationship we have between perimeter and area for a square. As the area increases, the perimeter increases too. The ratio of area to perimeter of a square is the length over 4, and as the area increases by increasing the length, the perimeter increases as well to preserve the given ratio. Similarly, for a circle, the value of area and perimeter are related in the same way. As the area increases, the perimeter increases as well. In general, our intuition for any shape is that as the area increases, the perimeter for that shape increases as well. The rate of increase might be different for different shapes, but nevertheless it does. Well, the relevant question Isaac might be asking then is the following. Why is that intuitive? And a reasonable answer to that would be, as the area is to be increased, I must have more boundary length, that is the perimeter, to span over that area. In this video, exploring something that defies that intuition. Can there be a shape that has zero area but an infinite perimeter? We are talking about a shape called Sierpinski triangle. It lies in a family of self-similar shapes called fractals. We do not need to know about fractals for the purpose of this video. Named after a Polish mathematician Warsaw Sierpinski, Sierpinski triangle needs an equilateral master triangle to start with. Then we remove another equilateral triangle from the earlier master triangle. The removed triangle is a half version of the master triangle. And this process can be repeated for as many levels as the stick denizens want. Now, let us consider that the area of the master triangle is 1. Then the area of the removed triangle in level 1 must be 1 by 4. Note why that is the case. Since this triangle is a scale version of the master triangle, both the base and height of this triangle are halved, meaning that the area is reduced by a factor of 4. For any nth level, we can reasonably say that each removed triangle has an area 1 by 4 raised to the power of n, where n is the level of that removal. Let's now count how many triangles are there in each level of removal. Initially, there is just one removed triangle. That is followed by the removal of 3, 9, and 27 triangles as the level increases. That can be generalized to 3 to the power n minus 1 triangles. So if we are asked to guess what area of the master triangle is removed at the nth level, we can say that the area removed is the product of area of each removed triangle times the number of triangles. We would then want to sum that over infinity. Using geometric sum formula for r is smaller than 1, and assuming that we are constructing an infinite Sierpinski, the area removed is tada 1. No kidding at all. After removing triangles up to infinite levels, the area remaining is 0. Very surprising. Now, let's go to another prong of this video. What about perimeter after infinite area removal in Sierpinski? Let us start by considering that the master triangle has a perimeter of 1. The perimeter of the removed triangle at level 1 will be half, as the triangle is scaled by half at each level. Then the perimeter of the whole shape at that point will be 1 plus 1 by 2, the sum of perimeters of all triangles in the shape. Note how the removal of area has increased the perimeter of the shape. If we remove area up to n levels, the perimeter can be expressed as the following formula. Pause the video and ponder why that might be true. I think the red stick denizen got it right to some extent. Can you solve it now? Now, as n approaches infinity, the sum diverges to infinity. It means that upon infinitely removing area from the master triangle, the perimeter of the shape blows up to infinity. The pink denizen is on the right track this time along, so presenting you a shape that defied our expectations. A shape with an area of 0 and an infinite perimeter. Let me know if you found that interesting. Also a postscript. Even though the channel name references BoJack Horseman, the creator wholeheartedly vouches for Todd Chavez as a favorite character of the series BoJack Horseman. Thanks for watching and follow for more content in the future.